Hello, we are going to do solving linear equations, and we're going to deal with some of the more challenging problems today and some of the word problems. So there are many ways to solve linear equations. So if you find a different way to get the same answer, that is totally fine. We all see things differently. As long as you show your work on how to get there, that's fantastic. So looking at number one, what I see here is it has this minus 8. So what I'm going to do is I'm going to move 8 to the other side. As I'm doing that, I'm noticing that two in the plus 8 over 3 equals 40. Now, I know we practice this through loop sometimes, so what we do is we get rid of fractions and multiply both sides by 3. When we do that, the 3 by 3 undoes each other. So on the left side, we just have x plus 8. On the right-hand side, we have 101. Now, in order to get x itself, we're going to go ahead and subtract 8. And then we are going to divide by 2. So we get x equals 56. What you can do is you can go ahead and take this and plug it back in your equation for x. See if you get a true statement like 32 equals 32. When you do that, you'll see that this is the correct solution. Now let's deal with some fractions. So 1/3 x plus 6x minus 4 equals 7. Looking at this, again, we don't really like dealing with fractions. So what we can do is we can get rid of fractions. We're going to multiply the entire equation by a number that's going to clear all of the fractions out. So if you look at 3 and 5, those are our denominators. So find all of the denominators in your problem. You want to think about what is the first number and 5 both go into. I'll say it again. What is the first number 3 and 5 both go into? And yes, that would be 15. So once you find that number is the one that you split the entire equation by. Our first fraction by 15, our second fraction by 15, we're going to multiply 4 by 15, and 7 by 15. So when we multiply 15 times 1/3, I'm going to put that over here. 15 times 1/3. You're going to treat this as 15 over 1 times 1/3. You're going to multiply the 15 and the 1 because they're the numerators. And you're going to multiply the denominators together, the 1 and the 3. And so 15 times 1/3 becomes 15 thirds. That's going to simplify 5. So when I do 15 times 1/3, that is going to become 5 in front of my x. Now let's go ahead and do the next one. I'm going to show this one, 15 times 2/5 over here. I'm going to do 15 times 2/5. And again, we're going to treat this as 15 over 1. You multiply the numerators. 15 times 2 is 30. 1 times 5 is 5. So multiply the numerators, multiply the denominators, and then reduce. So 30 divided by 5 is 6. This should happen if we are finding the right number to multiply by. All of our fractions should be gone. So 15 times 2/5 x is going to be 6x. And then we're going to do minus, we're going to do 15 times 4, which is 60. Then we're going to do 15 times 7, which is going to be 105. So we first found whatever the denominators are, the first number that they go into nicely. So 5 goes in 16. You take that number and you're going to multiply each part of your equation by that number. All of your fractions reduce to nice numbers. And then from here, put to this equation, the 5x plus 6x minus 60 equals 105. You do that and say, hey, yeah, I can solve that. I'm going to combine 5x and 6x together. That's going to be 11x. I'm going to go ahead and move the 60 to the other side. So we get 11x equals 165. And then we're going to divide by 11. And we're going to get that x equals 15. Okay, so let's try another one. Ooh, now this one has 3 different fractions. So we're looking for the first number that 2, 4, and 7 go into. So you can kind of think through some of your multiples of 4, you can think through some of your multiples of 7, but ultimately the first number that they all go into nicely is 28. So what we're going to do is we're going to take the entire equation and we're going to multiply by 28. So let's do this first by 28 times negative 3 sevenths. So I'm going to do 28 times 3 sevenths, and then I'll make it negative. When I look at this, I'm going to do 28 times 3. We're going to multiply the numerators. When I do 28 times 3, I get 84. I'm going to do 1 times 7, which is 7. Excuse me. And this is going to be negative. So this first fraction, we're going to go ahead and reduce negative 84 sevenths, and that's going to become negative 12. Now I'm going to go ahead and multiply 28 times b. So plus, it's going to be 28b equals, I'm going to multiply 28 times 3/4. So I'm going to show that here. 28 times 3/4. Excuse me. We're going to do 28 over 1, and we're going to multiply across. So 28 times 3 is 84. 1 times 4 is 4. And 84 divided by 4 becomes 21. So therefore, 28 times 3/4 becomes 21. And now we're going to multiply this last one. We're going to do 28 times b over 2. I'll show that work over here. So 28 times b over 2. So we're going to put 28 over 1. We're going to multiply across and get 28b. 1 times 2 is 2. And we can actually reduce these numbers because it's 28 times b. So that b could really be written as afterwards. It's the same thing, okay, because it's all multiplication. You can kind of move it around a little bit. So we're going to do 28 divided by 2, which is 14, and then it has the b with it. So this is plus in the equation, and that's going to become 14b. And now at this point, this is an equation that we can solve. We're going to go ahead and put all of the b's on one side. So I'm going to subtract 14b. And then I'm going to move the 12 to the other side. And I should have mentioned this earlier. If at any point in time this is going too fast, you can always pause the video and try a little bit yourself and then unpause it. So now we get 14b equals 33. We divide 14 and we're looking at this and it doesn't look very nice. So the first question is, can you reduce any of this? You can't reduce by 3 or 2 because it doesn't go into both 33 and 14. So ultimately, when you have a fraction like this, we're just going to leave it like this. It's going to be, you can leave things as improper fractions. Fractions are going to be preferred over the decimal because fractions are the exact same thing. The decimal ends up being rounded. So b in this case equals 33 over 14. Okay, so there were some more challenging solving equations. Now we're going to get into some word problems. And we're going to talk about consecutive integers. You're going to see that word a lot, consecutive, and specifically integers. So consecutive means in a row, okay, in a row. So if you're talking about consecutive houses, it's like your house, the house next door, and the house on the other side. So they're in a row, they're not like across the street, okay, in a row. Integers, as you remember, the integers are going to be numbers on your number line. So it's going to be numbers that are in a row. Okay, so examples of that would be 1, 2, and 3, or -4, -3, -2, -1. You can have any number of consecutive integers. So if I said 5 consecutive integers, you could go 1, 2, 3, 4, 5. Okay, so as long as they are in a row. So in the word problem, they're going to of integers, and we're not going to know them. So it's going to say like 3 consecutive integers or 5 consecutive integers. And if you don't know them, we're going to need to come up with variables to represent them. So the first one, if you don't know it, we're going to call it x. Or actually, you know what, I'm going to use a different variable. I'm going to use the variable n. It doesn't really matter what variable you use. So if you don't know that, the first integer in all of them, we're going to call it n if we don't know it. Now we need a way to get to the second integer. So this one was the first, the next one is the second. So let's look at this. If 1 is my integer, how do we get from 1 to 2? Well, if you're thinking from 1 to 2, all you do is add 1, which means if we don't know the first one, to get to the next one, all we're going to do is add 1 to the last one. That's going to be what makes it in a row. To get to the third one, normally we just add it again. So from our initial one, if this started out at 10, we are now 1, 2 away from our initial one. So that's going to be n plus 2. And you can keep on adding more. The fourth unknown would be n plus 3. So for instance, I said the first number was 64. And I asked you, what are the next two? If the first one is 64, you add 1 to get to the next one. And from 64, you would add 2 to get to the next one. That's what these unknowns represent. So you might also hear the word even consecutive integers. But talking about the even numbers that are in a row. So that would be 2, 4, 6, 8, 10. These are even consecutive integers. Or you could even do negative. It could be negative 44, negative 42, negative 40. So in a word problem, you might talk about even consecutive integers. You might not know what they are. So to label them, the first one is going to still be n. Okay, that's still going to be our first unknown. And then you might ask yourself, well, how do I get from one even number to the next even number? So looking at 2, if you go from 2 to 4, what's happening here is you're adding 2. So if your first unknown is n, to get to the next one, you're adding 2 from there. So the second one we're going to label as n plus 2. Then to get to the next one, so let's say going from 4 to 6, now you're adding 2 again. But if you're comparing how you get from 2 to 6, if your first unknown was n, you actually have to add 2 more, which makes it overall adding 4. So again, that's in a word problem. If you don't know how to label even consecutive integers, you're going to do it n plus 2, n plus 4, and if you need more, you would keep adding 2. So now add consecutive integers has the exact same idea, but now it's for the odd numbers, 1, 3, 5, 7, etc. Or again, it could be negative, -7, -5, -3. In word problems, if we're talking about odd consecutive integers, the first one we're still going to label as our variable if it's unknown. So if we don't know what it is, I call it n. Okay? To get from 1 to 3, you might think, hey, it's odd, so my numbers are going to be n plus 1 and n plus 3, but that's not how this works. How do you get from 1 to 3? How far apart are they? Well, they're 2 apart. So for odd numbers, it's going to seem counterintuitive, but from 1 to the next, you're still only adding 2. You're not adding an odd number. They're separated 2 apart, which means to get to the next one, you're adding 2 again, which means we're overall adding 4 from the first one. Now, this looks like a lot, so let's go ahead and dive into some problems so we can see this in action. So I'm going to scroll out a little bit, zoom out so that you can see all of our notes here and how it applies now to this problem. So the sum of 3 consecutive integers is 132. Okay, so looking at this, what this is saying is 3 numbers in a row add up to 132. And if you are someone who can figure this out in your head, awesome. what I would like to do then is show me why it works. So show me them all adding up to 132 and write down specifically what those numbers are. But if you're looking at this and saying, I don't know how to do this, let's go ahead and make an equation to represent this. So what I'm going to do is I'm going to say consecutive integers. I have my first, my second, and my third. I'm adding 3 of those together. I don't know what my first one is. Since it just says 3 consecutive and it doesn't say odd or even, I'm going to use those up there. So my next one would be n plus 1, and my third would be n plus 2. So I have all my labels here. These are the 3 numbers I'm going to take the sum of. So now that I have it labeled, I'm going to go back and read the other part again and make sure I would set up my equation the right way. So the sum of these is 132. So all of these, we're going to take the sum and say that is 132, which means we're going to add together 3 numbers to get 132. And since I don't know what these numbers are, I'm going to take my labels from over here and say this is my first number, my second number, and my third number. I don't know what they are, so I'm going to use n for my first number. I'm going to use n plus 1 for my second number, and n plus 2 for my third number. So looking at this, now I have taken and I have labeled everything. This equation that we've written is one that I can actually solve. So I'm going to go ahead and combine like terms. I see 3 n's. 1 plus 2 is 3. And now I can solve this equation. So I'm going to subtract 3. And then I'm going to divide by 3. And I'm going to get n equals 43. So now what we've done is we've solved for n. What I need to go do is go back and reread the question. It's asking, what are the 3 integers? Right now, I just have a number. I have n. But if I go back to my labels, if n is 43, that means my first number is 43 because it's n. And if I add 1 to that, it's going to be 44 because it's 43 plus 1. And if n is 43 and I add 2 to that, I'm going to get 45. You can always double check this by adding them together and seeing that they do in fact equal 132. So the 3 numbers are going to be 43, 44, and 45. Let's take a look now at the next one where it talks about odd integers. So the sum of 3 consecutive odd integers is 57. So I'm going to just again label, there's 3 of them because there's 3. So first, second, third. I don't know what these are. I'm going to call my first one n. And it says consecutive odd integers. So what I'm going to do is I'm going to go back in my notes. I'm going to see that odd consecutive integers are labeled as n, n plus 2, and n plus 4. I'm going to go back here and I'm going to label this as n plus 2 and n plus 4. So even though it says odd, yes, I know that, it does, we're still going to use plus 2 and plus 4. So what we're doing is we're saying the sum of these is 57. In other words, one number plus the next equals 57, and all of them are odd. So we don't know what the first, the second, or the third numbers are, but we know we're going to use our labels from over here. Our first number is n, our second is n plus 2, and our third is n plus 4. After we have our equation set up, what we're going to do is we're going to combine like terms. So once again, I have 3n, and then I'm going to combine 2 and 4 together to get 6 equals 57. This is something we can solve. So we're going to subtract 6. We're going to get 3n equals 51. We're going to divide by 3, and we're going to get n equals 17. So we go back and we look for this. What are the 3? And you're going to go ahead and plug it in. So the first answer is 17. 17 plus 2 is 19. 17 plus 4 is 21. Well, this works. We're going to add them all together. We're going to get 57 plus add in. Yes, 17 makes 21 are all odd numbers. If we have, we did something wrong. We're going to do the numbers are 17, 19, and 21. So that is it for our notes for today. Thank you very much. I hope you have a great day.